Hello everyone. Welcome to the Study of Basic Statistics course. I am Chen Jinti from Guangxi Financial Vocational College. Today we continue to learn Project 4, the fourth learning task of descriptive statistics, to know the index of variation of indicators. In the previous learning, we have mastered average indicators. We can understand the commonness of the data as a whole, but knowing the average alone is far from enough. For example, the monthly sales of two sales teams are 100,000 yuan. Team members' performance is not much different. Team B is very different. Can we just rely on the average? Can we say that the performance of these two teams is the same? Of course not. At this time, we need to use variance indicators to reveal the differences between individuals in the data, that is, the overall personality, to help you better understand. This class will focus on two core knowledge points. First, the basic concept and practical application of indicator variance. Second, the types and calculation methods of common indicator of variation. We will also combine with innovation and entrepreneurship cases and social reality to guide you to use statistical thinking to observe problems, analyze phenomena, and optimize decisions. Let's first look at what a sign variation indicator is. In layman's terms, variation indicator is used to describe how much difference there is between data. It refers to the overall, the degree of difference in the value of each unit, also known as dispersion or central tendency. Abbreviation of variance indicator, it and average indicators together constitute a double description of data. The average indicator shows where the data is concentrated. The variance indicator reflects whether the data distribution is scattered, and stability. Let's understand it through an example. For example, Group A, 65, 68, 72, 75. The average grade is 70. Group B's grades are 34, 51, 95, and 100. The average score is also 70. Although the average scores are the same, but the scores in Group A are more concentrated, and the average is more representative. The variance of Group B is large, and the average is less representative. The second example is about the wages of Group A and Group B. The average salary of both groups is 100 yuan. But as you can see, the salary of Group A fluctuates greatly, and the fluctuation in Group B is small, which shows that Group B is more stable, and the average is more reliable. What are the functions of the index of variation? First, it measures the representativeness of the mean. The smaller the value, the more representative the average is. The larger the value, the worse the representation, indicating that the data fluctuates greatly. Second, reflects the balance and rhythm of social and economic activities. Small variance indicates it means the situation is stable and balanced rhythm. The larger the variance indicator, indicating significant differences and unstable operation. Third, it measures the degree of risk. In investment or entrepreneurship, the greater the fluctuation, the higher the potential risk. Let's look at this question. Which of the following is not a function of a variation index? First, let's recall what a variation index does. It is a statistical measure that describes the spread of data. Let's go through each option one by one. Option A, indicate whether the average is reliable. A variation index directly reflects how representative the average is, so this is a function. Option B, measure the dispersion of data. This is the core definition of a variation index, so it is definitely a function. Option D, assess the volatility of the phenomenon. A variation index quantifies the fluctuation of data, so this is also a function. Now option C, increase the number of samples. A variation index is calculated from existing data. It cannot increase the sample size, so this is not a function of a variation index. Therefore, the correct answer is C. Next, let's take a look at the types of indicators of variation. It includes range, mean deviation, standard deviation, dispersion coefficient. The first one, the range, is the simplest measure of dispersion. Its calculation method is to subtract the minimum value from the maximum value. For example, the highest temperature in a certain place is 35 degrees, and the lowest temperature is 20 degrees Celsius. So the total distance is 35 to 20 to 15 degrees Celsius. This method is intuitive and easy to understand, but it only reflects the difference between two extreme values. It cannot reflect the distribution of intermediate data. So when the sample size is large, or the data fluctuates irregularly, it has limited representativeness. Second, the average deviation. The average deviation is the deviation of each data, and the arithmetic mean. Arithmetic mean of absolute value of deviation. This definition may sound a bit awkward. We can slowly reason from this definition. Each data is x. Arithmetic mean x. The deviation is subtraction. The absolute value is taken, and then check the arithmetic mean. Then we are equivalent to. We add up the absolute value of the difference from the arithmetic mean, and add them up, and divide by the total number n. Our mean difference is expressed in A, D. The formula just derived. It is suitable for the case that the overall data organizing is still a case of original data. That is, our simple average deviation. For group data, how should we calculate the average difference? In fact, we should calculate the group average difference. That is, when we finally calculate the arithmetic mean, we need to use weighted average. Subtract the absolute value of x from x1 and multiply it by the weight f1. Add x to minus the absolute value of x, multiplied by weight f2. Keep adding to xn minus the absolute value of x times the weight fn, and then divide by the sum of the weights. Finally, a formula for the weighted mean deviation is derived. The average deviation is better than range, can more comprehensively reflect the dispersion of all data, but because of its complex calculation, it is less used in practice. The third standard deviation is the deviation of each data from its arithmetic mean, the square root of the arithmetic mean of squares. The square root of the standard deviation is variance. It is represented by sigma squared. The formula is shown in the PPT. It should be noted that the larger the standard deviation, the greater the degree of variation of the sign. The smaller the standard deviation, the smaller the degree of variation. Let's look at this question about standard deviation. Option A is wrong because standard deviation uses square differences, not absolute values. Option C is wrong because a higher standard deviation means data is more spread out, not more concentrated. Option D is wrong because standard deviation is very commonly used. Only option B is correct, so the answer is B. Next, let's look at the fourth type of dispersion coefficient, also known as the coefficient of variation. The coefficient of variation here is not an indicator, but a kind or a class of indicators. For example, the all-distance coefficient we mentioned earlier, mean difference coefficient, and standard deviation coefficient are all variation coefficients. Coefficient of variation. It is generally used to compare similar phenomena at different levels, especially different types of phenomena. The representativeness of the overall mean. The smaller the coefficient of variation, the average is representative. Conversely, the larger the coefficient of variation, the smaller the representative of the mean. Its formula is as follows. The coefficient of variation is equal to divided by arithmetic mean. Imagine that if you develop a self-made cultural and creative product and surveyed the satisfaction scores of 100 customers, and the average score is H. If the standard deviation is 0.5, does it mean that customer evaluations are concentrated and the market feedback is stable? If the standard deviation is 2.5, it means that our scores vary greatly and users' opinions are differentiated. There may be problems with product positioning or quality. This shows that in our daily data analysis, we can't just focus on the average. We should pay more attention to the volatility of the data behind it. So today, we have learned the concept and significance of index of variation, calculation and application of 4 common measures of dispersion, the practical value of statistical thinking and innovation. Please remember that average tells you where the center is, while our variance indicator will tell you how scattered the data is. Finally, please complete the homework. Think about, in your ideal entrepreneurial project, which variation indicator is the most suitable to analyze customer behavior or product feedback and explain your reasons. So that's all for this class. Thank you all.